All right, so today we are going to look at solving trig functions. So far, up to this point, you have really only proved identities, and now we're actually going to solve. So before we start solving, we need to take a look at this picture right here. Okay, so if you have this triangle, and we're trying to find sine of theta. So here's theta, which is your reference angle. Sine, remember, is just opposite over hypotenuse, so it's this side over this side. In a right triangle, don't forget your hypotenuse is always the longest side. So let's say your hypotenuse is 10. What could your opposite be? Well, it could be anything less than 10, so it could be 7. Okay, what if your hypotenuse is 3? Well, then your opposite would have to be 1. Okay, what are you going to notice about every single one of these fractions? Well, it's going to be less than 1. So do you think it could be equal to 1? Well, if you have a point that's out here, right here on the x-axis, technically you're going to have your opposite length is going to be 0, and your hypotenuse is going to be whatever this length is. So if this was at -1, 0, then your sine, remember sine is your y value, it's just 0. So this can actually be less than or equal to 1. So the sine of theta is always going to be less than or equal to 1. Okay, but what if we move our triangle down here? So we have the same thing as above, but now our opposite is below the x-axis, so it's going to be negative. So this would be like -7/10 or -1/3. So really, it has to be less than or equal to 1, but it also has to be greater than -1. Okay, so let's fill this in quick. So the sine of theta has to be in between -1 and 1. So for the same reasoning as sine, cosine has to be between -1 and 1. So let's go up here quick. And so now if we're talking about tangent, tangent is opposite over adjacent. So if this is opposite and this is adjacent, well, these two things can be any number they want, and it doesn't, like, they don't depend on one another. So tangent of theta can actually be between -infinity, holy smokes, that was a bad infinity. Not that that was much better, and +infinity. Okay, so now we can look at cosecant, secant, and cotangent. So remember, cosecant is 1 over sine. So let's go back up to our picture quick. So we're gonna write that. Okay, so if I write this here, so you know that oh my goodness, cosecant of theta equals hypotenuse over opposite. So now you know that the larger number is always on the top. So now instead of this fraction being less than 1, it's always going to be greater than 1 or greater than or equal to 1 or greater than or equal or less than or equal to -1. So this must be greater than or equal to 1 or has to be less than or equal to -1. So that's the same with secant. So greater than 1 or less than or equal to -1. And then cotangent, since tangent can be all real numbers, cotangent is the same. So from -infinity to infinity. So I would just make sure you write this down. The biggest thing you need to remember is that sine and cosine have to be less than or equal to 1, but they have to be greater than negative. So they have to be in between -1 and 1. Tangent can be all real numbers. Cosecant cannot be in between 1 and -1, and secant cannot be between -1 and 1. Okay, so let's move on. Okay, so these ones we don't have to solve. It just asks us, do the following, have a solution. Okay, so here's the first one. So when you are solving these, it's the same that you've solved for everything. So this is 3 times sine of x. Okay, so then you would just divide both sides by 3, and you're going to get sine of x equals -1/3. So is this going to have a solution? Well, is -1/3 in between the two numbers that we said? Yes, so this is in between negative and 1. So this is yes. It's in between -1 and 1. Okay, this one over here, divide both sides by 3, and we get cosine of x equals -4/3. This is not in between -1 and 1, so this does not have a solution. Okay, so let's actually look at solving some. Okay, so here we want to solve for x. So like I said, it's the same thing as when you started solving in integrated 1. So you draw the line, subtract 5 from both sides. So we have 2 sine of x plus 5 equals positive 1. And then, oh my gosh, I am struggling today, you guys. Okay, so 5 minus 5, 0. Divide both sides by 2. So we have sine of x equals 1/2. Okay, so to solve for x, remember we can't just divide by sine. To get rid of sine, you have to take the inverse sine of both sides. So inverse sine of sine of x equals inverse sine of 1/2. So if you take the inverse sine of x, we get x equals, in your calculator, when you do the inverse sine of 1/2, I want you to actually pause your video and make sure you get the same answer as me. So you should get 0.5233 or 35. So if you don't get this, I need you to put your calculator into radians. If you don't know how to do that, send me an email and I'll show you how to do it quick. So what this is saying is x is 0.5235 radians. Okay, so now if you go back to your unit circle, so unit circle looks like this. We were trying to find where the sine of x is 1/2. So if you look at your unit circle, remember that sine is talking about your y value. So do you see anywhere on here where your y value is 1/2? Well, if you go to this first coordinate point, here's y, and here's 1/2. So pi over 6 is actually the same as that decimal that we got. But now, if you keep looking, there's another spot over here where your y value is 1/2. So your calculator is only going to give you one answer. You have to come up with both of them. So if you ever come up with a sine of x equals something that's on your unit circle, so if it comes up with square root of 3 over 2 or 1/2 or square root of 2 over 2, you have to go to your unit circle and find the exact value. This is an approximation. So our exact values are at pi over 6 radians and 5 pi over 6 radians. So now, believe it or not, we are not done with this problem. So I'm going to talk in degrees for a second because I think we our minds work a little bit better in degrees. So do you agree that right here, this is 0 degrees? But if I go around the circle, I'm at 360 degrees. If I go around again, I'm at 720. So this is really 0 degrees, 360 degrees, 720 degrees, and so on. So that means that this up here, if this is 90 degrees, well, it's also 360 plus 90, that's 450, and so on. Well, it works the same way when we're talking about radians. So let's get rid of this. So if this right here is 0 radians, it's also 2 pi radians. It's also 4 pi radians. This right here is pi over 6 radians. But if I go around again, you have to add 2 pi to it. If I go around again, you have to add 2 pi to it. If I go around again, and you can keep going around forever and ever. So really, it's going to be pi over 6 plus 2 pi, but that only is going around the circle once. To account for every single time you go around the circle, you have to multiply this 2 pi by n. So now this answer is here, but it's going around a million infinity times. Okay, so here's one answer, and then our second answer is going to be 5 pi over 6 plus 2 pi n. Yep, that is a lot of work for one problem. It's a lot of understanding. So if you need to go back, rewatch it. Otherwise, we're going to do a few examples. Okay, so now we're going to look at tangent. So let's pretend we have the tangent of x equals 1. Okay, so if you go to your unit circle, remember tangent is sine over cosine. So if you have, let me just write up here quick. So if you have sine of theta over cosine theta and you want it to equal 1, well, what needs to be true about your fraction? These two things have to be the same. So is there anywhere on here where your fractions are the same? Well, right here, we have square root of 2 over 2 and square root of 2 over 2. So we have pi over 4. So one solution is going to be at pi over 4. So now our other solution is going to be down here. So we have negative pi, or square root of 2 over 2 and negative square root of 2 over 2. So that's at 5 pi over 4. So let's pretend instead of positive 1, it was negative 1. Well, where's negative 1 at? Well, here's negative 1, and here's negative 1. So it's not a coincidence that if you have one solution here, that your other solution will be down here. If you have one solution here, your other solution will be down here. So when you are doing tangent, yes, you are going all the way around the circle to get back to your original point, but you can actually only go halfway. So, sorry if that was confusing. So instead of taking pi over 4 plus 2 pi n, we can actually just take pi over 4 plus pi n. So it'll stop here, then it'll stop here, then it'll stop here, then it'll stop here. So whenever you have tangent, the two solutions that you get are actually only pi radians apart from one another. So this is actually our solution. Could you put pi over 4 plus 2 pi n and then 5 pi over 4 plus 2 pi n? Yes, but you're really just saying the same thing twice. Okay, so here's a little note for you. So when finding all solutions of sine of theta, you're going to have two answers plus 2 pi n. When you're finding all solutions of cosine theta, you're going to have two answers plus 2 pi n. When you're finding solutions for tangent theta, you're only going to have one answer plus pi n. So if you're going to write something down, this is the one to write down. Okay, so I know everything that we've done today seems terrible, but these are some examples from your homework specifically. So let's just see what we can do. Um, so when you were solving, you do the same thing you did as when you were in regular one. Draw the line, subtract 1 from both sides. So we get 5 times cosine of x equals 2. Then divide both sides by 5. So we have cosine of x equals 2/5. So if this number was on your unit circle, you would go to your unit circle and find your values from there. Since it is not, we have to take the inverse cosine of both sides. So inverse cosine of 2/5, and that is 1.16. Okay, so here's one of our answers. So remember, if you're finding sine or cosine, you're going to have two answers. So 1.16. So let's go ahead and just draw where that would be at on our unit circle. So remember, 1.16, that is talking about radians. So here's 0 radians. Here's 3.14 radians. This is at about 1.57 radians. So we're looking for 1.16, which is, I don't know, somewhere in here. So let's just say this is at 1.16 radians. So how do we find where the other one is? Well, so we have cosine, right? Cosine is talking about your x value, and it's positive. So cosine is your x value, which is positive. So here, your x value is negative, so it's not going to be there. Here, your x value is negative, so it's not going to be there. So that means it has to be here. So now I'm just going to draw an example in degrees. Let's just pretend that this was at 30 degrees. And this coordinate point is at, oh my, why can't I think? So square root of 3 over 2 comma 1/2. So we're talking about the cosine value. So this cosine value is x. Where is the other x value? Well, it's down here. And we're actually just taking this and reflecting it down here. So this is where the other positive square root of 3 over 2 would be. But how do I figure out what degree this is? Well, if I'm taking this and just reflecting it down here, if this is 30 degrees away, it's going to be 30 degrees away here. So you would take 360 minus your 30 degrees, and this would be at 330 degrees. So now we can do the same thing up here. So if this is at 1.16 radians, we need to take this and reflect it down here. So this length or this angle measure is 1.16 degrees. This angle measure is 1.16 degrees. So you are going to, or not degrees, sorry, 1.16 radians, not degrees. This right here, it's at 0 or 2 pi, which is 6.28. So to find this, you're going to take 6.28 minus 1.16. 6.28 minus 1.16, and that is 5.12. So our answers are 1.16 and 5.12. This is radians. So that's just this point and just this point. You have to remember we can go around the circle. So we can take this plus 2 pi, plus 2 pi, plus 2 pi. So it's plus 2 pi n and plus 2 pi n. Okay, here's another example from your homework. So 3 times secant of x equals 2. So if I divide both sides by 3, you get secant of x equals 2/3. And guess what? We can stop here. There is no solution because this has to be outside of the range of -1 and 1. So this has no solution. And then up here, I should have showed you this. 2/5, that's in between -1 and 1. So we know that there's going to be a solution. All right, so let's go ahead and try cosecant of theta. Anytime you have cosecant, secant, or cotangent, just change it to the other one. So this is sine of theta, but then instead of 6, we actually have 1/6. 1/6, not on the unit circle. Shoot. So we have to take the inverse sine of both sides. So the inverse sine of 1/6 equals something. 0.167. So there's one of our answers. So we draw our circle. 0.167 radians, that's probably here-ish. So this is at 0.167. Sine talks about your y value. So we care about the y value. The y value, it's positive. So where else is our y value going to be positive? Well, over here. So we reflect across the y-axis. So if this is 0.167 radians from here, this is 0.167 radians from here. This right here is at 3.14. So you will take, to find this, we will take 3.14 minus 0.167. So 3.14 minus 0.167. And you get 2.973. And then you take both of these plus 2 pi n plus 2 pi n. And then I think I've got another one. I don't have it written down. Okay, let's look at this one. So we have 2 sine of x plus the square root of 3. So subtract square root of 3 from both sides. So we have 2 sine of x equals negative square root of 3. Divide both sides by 2. So sine of x equals negative square root of 3 over 2. This one is on your unit circle. We're talking about sines. We're talking about y. So here's our unit circle. So you want to find where your y is negative square root of 3 over 2. So our y value. So here's 1. And our other one should be right here. So our answers are 4 pi over 3 and 5 pi over 3. So x equals 4 pi over 3 and 5 pi over 3. And those are both plus 2 pi. So I'll put 2 pi r, that's not what I want. 2 pi n. Don't forget, if you have a tangent, you only find one answer and you add pi times n. All right, that's what we got for today.